Hello friends, welcome to a new video of I Square. We were discussing with the chapter sets and in today's class we are going to a new concept from the chapter sets, that is subset. What is a subset? For example, we have two sets A and B. When will we say that A is a subset of B? There is a condition to say that A is a subset of B, and the condition is every element of A should be there in B. That is the condition to say that A is a subset of B. For example, let A be the set 2, 4, 6 and B be the set 2, 4, 6, 8, 10. Now, we are going to check whether A is a subset of B or not. What is the condition for A to be the subset of B? The condition is every element of A should be there in B. And we denote A subset of B by A subset of B. This is the symbol to denote A is a subset of B. And here we are going to check whether A is a subset of B. In A we have 2, that is 2 belongs to A, which should imply, this symbol means implies. Now 2 belongs to A implies 2 belongs to B. 2 belongs to A, 2 also belongs to B, therefore one element which is in A is there in B. Now we will check for the next element 4. And 4 is also here, which means 4 belongs to A implies 4 belongs to B. Now going for the third element, that is 6. 6 belongs to A implies 6 is also here, 6 belongs to B. So it is clear that every element of A is there in B. So we can say that A is a subset of B, and we denote it like this: A is a subset of B. So that is the concept of subset. When we have two sets and we call one set the subset of other, for example A subset of B, only if every element of A is there in B. So now let's check whether some sets are subsets of other sets or not. In this question, we are going to check the following pairs and find which set is the subset of the other. And the first pair is set Q and set R. These symbols may not be familiar to you, but the sets are familiar to all of us. The set Q is the set of rational numbers. And we know that rational numbers are the numbers of the form P by Q, where P and Q are integers and Q not equals to 0. And set R, it is the set of real numbers. So Q is the set of rational numbers and R is the set of real numbers. And we know that real numbers is the collection of both rational numbers and irrational numbers. What is an irrational number? An irrational number is a number which is not a rational number. So set R contains both rational and irrational numbers, and Q is the set of rational numbers. So it is clear that all rational numbers are there in real numbers, because real numbers is the collection of both rational and irrational numbers. So we can say that set Q is a subset of set R. What about the set R? Is set R subset of set Q? No, because real numbers contains irrational numbers, but rational numbers set does not contain any irrational number. So our condition is not satisfied. Every element of R is not in Q. So we cannot say that R is a subset of Q. That means R is not a subset of Q. So this symbol is used to denote not subset of. So I hope you understood what is the concept behind the subset and not subset. If A is a subset of B, then every element of A should be there in B. If every element of A is not in B, then we say that it is not a subset and we denote it using this symbol. Now, what about the second question? Second question, we have set A as set of divisors of 56. That is the set of numbers which completely divide 56. We know that it includes 1, 2, 4, 7, 14, 28, 56. These all are divisors of 56. So this set A contains all the divisors of 56 and set B contains prime divisors of 56. That are the divisors which are prime, which include 2 and 7. So our set A contains all the divisors and set B contains only prime divisors. So it is clear that which set is the subset of other. Set B contains 2 and 7. Set A also contains 2 and 7. So it is clear that B is the subset of A. That is, the set of prime divisors is the subset of divisors of 56. So conversely, if we think, is set A subset of set B? No, because here we have 4, that is 4 belongs to our set A, but 4 does not belongs to our set B. Therefore, we cannot say A is a subset of B. So we can write it like this: A is not a subset of B. Now moving on to the third question. Here we have set A equals to set 1, 2, 3 and B is equal to the set of x such that x is a natural number. We know that natural numbers are 1, 2, 3, 4, etc. and x less than 6. So the natural numbers less than 6 includes 1, 2, 3, 4 and 5. So this is our set B. Now we have to check whether A subset of B or B subset of A. Now in A we have 1, 3 and 5. And in B we have 1, 2, 3, 4 and 5. Here 1 is in A, 1 is in B, 3 is in A, 3 is in B, 5 is in A, 5 is in B. So it is clear that A is a subset of B. What about B subset of A or not? Here we have 2 here, but here we do not have 2, which means B is not a subset of A. Now what about this question? A is equal to A, E, I, O, U and B is equal to A, B, C, D. Is A subset of B? We will check. A is here, A is here. E is here, but E is not here. E belongs to A, but E does not belongs to B. That means every element of A is not in B. Therefore, A is not a subset of B. Now, we can check conversely. A is here, A is here. B is here. Is there B here? No. Which means B belongs to B, but B does not belongs to A. Which means B is not a subset of A. So A is not a subset of B and B is not a subset of A. Now we have studied what are equal sets. Equal sets are sets, two sets are said to be equal, say A and B, if every element of A is in B and if every element of B is in A. Every element of A is in B means that A is a subset of B, right? Every element of A is in B means A is a subset of B. And now every element of B is in A means we have B is a subset of A. So what is the definition of equal sets? Two sets are said to be equal if every element of A is in B and if every element of B is in A, which means if A is a subset of B and B is a subset of A, we call A and B are equal. So A subset of B and B subset of A implies A equal to B. This is an important result. Always remember that if A subset of B and B subset of A, we can say that A equal to B. That is exactly the definition of two equal sets. Now we can solve some questions. Now in this question, insert subset symbol or not subset of symbol in these questions. So we have different sets given here. 5, A is equal to 1, 3, B is equal to 1, 5, 9, C is equal to 1, 3, 5, 7, 9. Now we have to check whether 5 is a subset of B or 5 is not a subset of B. We know that 5 means empty set or null set, which means a set which contains no element. So in order to check whether a set is a subset of another set, we have to check that every element of this set should be there in this set. So 5 does not have any element, so 5 is always a subset of B. And note that 5 is always a subset, that is an empty set is always a subset of every set. That is 5, which is the empty set, is always a subset of every set. This is an important result. Also remember that a set is a subset of itself. For example, we have A is equal to 1, 3. So we can say that A is always a subset of A itself. That is A have 1, 3 and here also A have 1, 3. So 1 is there in 1. In every element of A is there in A. So we can say that a set is always a subset of itself. So that is another result. Every set is a subset of itself. So a set always have two subsets, that is the empty set and the set itself. A set always have two subsets, that is empty set and the set itself. And these two subsets are called the improper subsets. Improper subsets of every set. A set always have two subsets, that is the empty set and the set itself, and those two subsets are called improper subsets of a set. Then what will be the proper subset of a set? All the subsets except 5 and that set itself are called proper subsets. Proper subsets. All the subsets which is other than the empty set and the set itself are called proper subset. For example, here we have A is equal to 1, 3 and set 1 is a subset of set 1, 3 and set 1 is a proper subset of set 1, 3 while set 1, 3 is an improper subset of set 1, 3 because 1, 3 is the set A itself. So every subset which is not an improper subset is called a proper subset. And what are improper subset? The empty set and the set itself are the improper subsets of a set. Now 5, we already said that a 5 or empty set or null set is always a subset of every set. So 5 is a subset of B. Now check whether A is a subset of B. We have in A we have 1 and 3. We have to check whether B have 1 and 3. And in B we have 1 but we do not have 3. Therefore we can say that A is not a subset of B because every element of A is not present in B. Now we have to check A is a subset of C or not. A is a subset of C or not. We have 1 here, 1 here. We have 3 here and 3 is also there in C. So every element of A, that is 1 and 3 is there in C, which means A is a subset of C. Now we have to check whether B is a subset of C. In B we have 1, 5 and 9. We have to check whether C have 1, 5 and 9. C have 1, 5 and 9, which means every element of B is there in C. So therefore we can say that B is also a subset of C. And all these two subsets were proper subset and 5 was an improper subset of set B. Hope you understood what is an improper subset and a proper subset. Now there is one more set we will say is singleton set. What is a singleton set? A set containing a single element is called a singleton set. That is, a set which contains only one element is called a singleton set. For example, set 1 or set B or set X or set 2. These are examples of singleton set. What is a singleton set? A set which contains only one element is called a singleton set. Now we can discuss what are the subsets of real numbers. What are subsets of real numbers? These sets are quite familiar to us. That is the set of natural numbers. What are natural numbers? 1, 2, 3, 4, etc. These are natural numbers, and it is clear to us that natural numbers are always a subset of real numbers, because real numbers contains both rational and irrational numbers. And what about whole numbers? Whole numbers are 1, 2, 0, 1, 2, 3, etc. And this is of course a subset of real numbers. What about integers? Integers are the numbers 0, 1, 2, 3, etc. Again minus 1, minus 2, etc. These are integers, and integers are also a subset of real numbers. And rational numbers. Rational numbers are the numbers of the form P by Q, where P and Q are integers and Q not equals to 0. We know that real numbers are collection of both rational and irrational numbers. Therefore, rational numbers denoted by Q is a subset of R, and Q dash, which are irrational numbers, is also a subset of R. These subsets are always or quite familiar to us. Now, let's discuss what are these subsets. What are these sets, and are these sets subset of real numbers? Now, this is read as closed interval A, B. See this? Here we have square brackets, and this particular set is read as closed interval A, B. And this particular set contains the set of all x such that A less than or equal to x less than or equal to b, and x belongs to set of real numbers. Which means this particular set, that is closed interval A, B, contains all the real numbers between A and B, and it also contains A and B, which means it contains all the real numbers between A and B. For example, take A is equal to 2 and B is equal to 5. Then this particular closed interval 2, 5 contains 2, 5 and all the real numbers between 2 and 5. It contains 2, it contains 5 and all the real numbers between 2 and 5. That is closed interval A, B. Now moving on, what is this set? This set is read as open interval A, B. Note that here we do not have square brackets, we have ordinary brackets, and it is read as open interval A, B. Then what are the elements this set contains? It contains the set of all x such that A less than, x less than, b, and x belongs to set of real numbers. So, note the difference. Here in closed interval A, B, we have A and B and all the real numbers between A and B. But in open interval A, B, we do not have A and B, but then all the real numbers between A and B. Always remember that open interval A, B does not contain A and B, but it contains all the real numbers between A and B. Now, what is closed interval A, open interval B? That is closed A and open B. Use your logic. It is the set x such that, set of all x such that closed interval A, that is A is included in the set, and all the real numbers between A and B, but B is not included in the set. So, note this. That is the closed part. That is A is contained in the set but B is not contained in the set, and it also contains all the real numbers between A and B. Now what is open A closed B? Use your logic again. It is set of all x such that open means A is not contained in the set but all the real numbers between A and B are there. Since B is closed, we have B also in the set. So this is the set open A closed B. It contains all the elements, all the real numbers between A and B and also B. And in real number system, we denote these sets like this. That is, in real line, we denote like this. This is A, this is B. It contains all the real numbers between A and B and A and B. So this is the closed interval A comma B. What is open interval A and B? A, B, and A is not there, B is not there, but all the elements between A and B are there. Now what about closed A, open B? Closed A, which means A is there, B is not there, and all the elements between A and B. Now what is open A, closed B? Which means A is not there, B is there, and all the real numbers between A and B. This is the number line notation for these sets. And remember that all these four intervals, that is closed interval A comma B, open interval A comma B, closed A, open B, closed open A, closed B, these intervals are subset of real numbers, and these two intervals are sometimes called half open or half closed intervals. This is called closed interval, this is called open interval, and these two intervals are called the half open or half closed intervals. Now we are going to learn what is a power set and what is a universal set. Consider this set. Set A is equal to 1, 2 and 3. We know that this is a finite set because the number of elements in this set is 3, and we are going to list out the subsets of these sets. First we will list out the singleton subsets, and we know that a singleton set is a set which contains only one element, and the singleton subsets of A are set 1, set 2 and set 3. So these three sets are subsets of set A. Now we are going to list the subsets which contain two elements, that is set 1, 2 is a subset of this set. Again set 1, 3 is a subset of this. Set 1, 3 is a subset of this set, and set 2, 3 is also a subset of this set. Now we already said that an empty set and the set itself is always a subset of a set. So empty set is a subset of this set, and the set A itself, that is A is equal to 1, 2, 3 is also a subset of this set. These two are improper subsets and all others are proper subsets. So we have listed out all the subsets including both proper and improper subsets here, and I am making this set of subsets a set. That is, this bigger set contains all the subsets of set A, and this bigger set is called power set of A, and it is denoted as P of A, and it is called power set of A. So what is a power set of a set? For a set A, its power set is the set which contains all the subsets of A, that is all the proper and improper subsets of A. Now moving on to the next type of set, that is universal set. What is a universal set? A set which contains a set is called a universal set. Basically, a universal set is a wider set. For example, if we are considering a study of a set of humans in India, we can set the universal set as all the humans in the world. For example, if we are studying about the even numbers set, that is 2, 4, 6, 8, etc. This is our set, and we are also studying about odd numbers, that is 1, 3, 5, 7, etc. If we are studying sets like odd numbers and even numbers, then the universal set is the set of natural numbers, or the universal set can be chosen as set of real numbers, or the universal set can be chosen as set of integers, because all these sets contains these sets, that is all these sets are subsets of these bigger sets. So universal set is always a larger set which contains all other sets which we are concerned. So I hope you understood what is a power set and what is a universal set. So in today's class we have learned major concepts like subset, proper subsets, improper subsets, singleton sets, power sets, universal sets, and we have discussed some problems related to all these concepts. So in the next class we will solve exercise 1.3. Till then wait for the next video. Thank you for watching. Bye bye.